Alright, so we're going to continue on with the other trig functions that we need to learn how to graph. So far you've learned cosine and sine and their reciprocal functions, which are secant and cosecant respectively. So we've learned 4 out of the 6 trig functions and how to graph them. Now what we're going to be looking at are the last two, tangent of x and its reciprocal function, cotangent of x. In all of the videos, what we started out with so far is graphing the parent functions, so this one's no different. So what I've done here is I've graphed the parent function of tangent of x, and as you can see, it's a whole different shape compared to the sines, cosines, secants, and cosecants. Cotangent is very similar to tangent, except you're going to see that it's flipped. It's going down instead of up. And then there's also somewhat of a shift going on compared to the tangent. But the first thing that I want to identify is we're going to be using the same steps that we have been using all the while. So whenever we were graphing cosine or secant, regardless of whether it was a reciprocal function or one of the main ones, what we always started out with was period. And period for tangent and cotangent are different from all the others. They are pi. It's not 2 pi any longer. It doesn't take 2 pi for it to start to repeat itself. If you can look at my function here, I use the same xy coordinate grid that I did for my sine and cosine. So what I did have to look at was make some more key points in here. So I had to do the in-betweens. So I can kind of show you. Up here, we just went by pi halves, pi, 3 pi halves, 2 pi. That got us a full cycle. What I have to do here was do some in-betweens in between my 0 and pi over 2. So there would be technically a pi fourths here. But what you can see that's going on is if you were to trace this edge and then go down from this edge, it's after pi that you would start repeating yourself, doing identical movement as what you did in the start with. So it only takes pi, or the unit or the full time of pi, to actually get some repetition going on, unlike sine and cosine. So that's one big thing. But other than that, everything else is the same. What we have to do is calculate the period, which is always going to be that period, the original period, divided by b. So for tangent, just like for the sine and cosine, what you would look at is what's being multiplied to the x. Right here, nothing. It's technically 1, but had there been a 2, what we would do to calculate the transformed tangent function would be take our original period, which is pi for tangent, and divide it by that 2, or divide it by that multiplier to the x. So in this case, what we're going to be getting is pi divided by 2, had this been 2. Okay, so that's how you would calculate your period, and just as importantly to calculate period is your key points, because that's what tells you, that's what you know to go by on the x-axis. So just like the sine and cosine, we're going to still quarter that period. So for this one, my parent function, since the parent function of tangent is just a period of pi, I'm going to quarter that and I'd get pi fourths. So you would see here each one of these little tick marks is going by pi fourths. Here's 1 pi fourths, 2 pi fourths, which simplifies to be pi over 2, 3 pi fourths, and 4 pi fourths, which simplifies to be pi. Alright, the reason why what we use these as our key points is it's on the unit circle. What you're going to get are some solid, nice numbers to work with at that quartering of a pi. So here is my pi, and if I were to ask you what is tangent of 0, well, remember tangent is the opposite over the adjacent, or TOA, but also it's known as the y over the x. So here, what is this point right here? It's 1 comma 0. So if you were to take the y over the x, it would be 0 over 1. So for tangent of tangent of 0, what is that y value? What's that output? It's going to be 0. So that's why we have start at the midline. Okay. Then what we're going to look at is pi fourths. At pi fourths, if you look on your unit circle and the point that it is on the unit circle, and we do need these memorized by the test, it's one of those, the square root of 2 over 2, comma the square root of 2 over 2. It's that 45, 45, 90 triangle on that unit circle. So being that if we have a hypotenuse of 1 and it's a 45, 45, 90 triangle, the two legs are those lengths, then if I'm calculating tangent, the opposite over the adjacent, or the y over the x, we're just going to get 1. So that's where it's going to technically reach up to its amplitude, though we can't call it amplitude anymore because it's not the distance from the midline to the highest point. But I mean, in all regards of what we've been looking at in the past, it is the amplitude. So here technically what's being multiplied on the outside, what's being multiplied to this trig function is a 1. We're just going to go up 1. Had it been 2, we would be going up as far as 2. Okay. Here what's interesting at pi over 2 is this point on the coordinate grid and on the unit circle would be 0, 1. So this is where we would take y over x, 1 divided by 0. You are going to get undefined, so that's why we have an asymptote there. Same thing over here. We have a negative square root of 2 over 2, comma, square root of 2 over 2. So when you take the tangent of that point, it's going to be negative 1. So that's why we're going to start down here, back to the center line, and everything starts to repeat. Okay, so there is the parent function there. Cotangent, key thing about this is your period is pi, key points are going by pi fourths because you quartered your period, and you start at your midline at 0. Okay. Cotangent is slightly different. I'm not going to go over this look of it, but what you're going to see is it's kind of just this shifted over a bit and then flipped. So key thing is still period of pi. You still quarter the period, and then the asymptote actually starts you out on that start at 0. You're not going to be starting at the midline. It's an asymptote, and then you're going to go up to your highest, well, not to the highest point, but up to the so-called quote amplitude, down to your center, down to your amplitude, asymptote, repeat. Okay, and all that once again happened within this realm of pi. I'm going to do number 29 with you, which is graphing y equals tangent of x over 3. I am going to rewrite this as y equals tangent of 1/3 x. Same thing. Okay, so I'm going to start out with my period just as I've always been doing, trying to find out my period. I need to keep in mind that it would be my original period of this function divided by b, and I can see that I do have a multiplier directly onto the x, so my period will be changed. But don't forget, I'm using pi as the original period because that's what it is for the parent function of tangent. Pi is the original period divided by 1/3. So when I do calculate this out, my period is 3 pi. Okay, key point intervals now. Key point intervals, or key points, are going to be this quartered, so 3 pi divided by 4. And that. Okay, so I don't have anything else going on with this, so I'm going to just graph it. I'm going to do 2 full periods, so I'm going to put this as my 3 pi in order to get 2 periods going on here. So tangent, key points are going to be 3 pi fourths. This is 2 3 pi fourths, which would be 6 pi fourths. That would simplify. This is 3 3 pi fourths, so 9 pi fourths. This is 4 3 pi fourths, which would be 12 pi fourths, which you could simplify down to this. This is 5 3 pi fourths, so 5 times 3 is 15. This is 6 3 pi fourths, so 18 pi fourths, 9 pi halves when simplified. Oh, this one's going to be, what am I at? 7 3 pi fourths, so 21 pi over 4. And then finally we have 8 3 pi fourths, which is 24 pi over 4, which would simplify down to 6 pi. That is a pi. Alright, so amplitude, or what we could call amplitude, here is just regular old 1, so I know I'm only going to go as far up as 1 and as far down as -1 for when I'm doing some of these key points, and it's my guide of this tangent. So I'm going to... Alright, so tangent, once again, starts on the midline, and then it's going to go to the amplitude. At that second key point, we have an asymptote. Okay, so I'm just following that basic parent function shape. I have a -1, center, and then 1 because of my so-called amplitude. Oh, shoot. And then same thing Okay, so I'm going to go ahead and draw through these guided plot points that I've done, getting closer to that asymptote but never crossing. Oops. There. Yeah, so I guess I technically didn't have that because I didn't plot that, but what you can see here is I started repeating myself at that first period that I had as 3 pi, because here was that movement and then I did the other part of that squiggly, and then here was that same movement again, so that's where I started repeating myself. That's where that period started replicating. Okay, so we're going to do number 35, and what you can see going on here is I have some sort of change in my amplitude, or in those key points that I'm going to be graphing, and then also I have this addition or subtraction directly onto the x. It's in the parentheses with the x, so it's directly attached to that x. So we know, just like when we're doing cosine and sine, if that's ever the case, adding or subtracting onto the x, then it's a horizontal shift. It's to the left or the right, and it's the opposite of what you would think, because that x is tricky. So we're going to be doing not to the left like you would think, because though it's being subtracted off, what we're going to be doing is to the right. We're going to be moving forward. So just as always, I'm going to calculate my period, and this is cotangent, so it's right along with its brother tangent. Its typical period would be pi, and then we would look, is there anything being multiplied to the x? Technically it's 1, so nothing really. Nothing's going to affect the period. Key points, I'm going to be doing pi divided by 4, because I'm going to be quartering that period. Amplitude, there is a change to the amplitude. I'm going to call it 1/4 of an amplitude. And then I have, technically, once again, amplitude is not the correct use, because what amplitude means is the distance from the maximums and minimums to that center line. So we have an infinite distance from the center line for cotangent and tangent, but I still tend to call this amplitude. It's the vertical stretch or shrink is the more correct term. And then we also have a shift, and it's a horizontal shift, H shift, and then it's to the right, pi over 2. So this is what I typically do for this. I draw that x horizontal axes like I would had there not been any shift. So I would just be saying, alright, here would be my 0, and I would know that my full period would have been pi, okay, and I would have had to quarter it, and I get pi fourths, pi halves, 3 pi fourths. But the thing is, now that I have that, what I can do is calculate what would be all of these points had I added pi over 2 to each one. So if I take 0, so my start would not be at 0 anymore. It's going to be 0 plus pi over 2, opposite of what you would think. So it would be pi over 2. First key point. So I'm actually going to draw this now, and I might have to shift this down here in a little bit, but if you want to, you can still include these, but this is my start. It would be pi over 2. It's not going to any longer be at 0. And then the first key point is going to be that pi fourths would have been the typical first key point, but I'm going to add pi over 2 to it, so pi fourths plus pi over 2, which is the same thing as 2 pi fourths. It's going to be 3 pi fourths, so no surprise. It's going to just be everything here. But 3 pi fourths, we need pi, we need 5 pi fourths. At this point I know that I'm going to just be going by 1 pi fourths at each step, so 6 pi fourths, I didn't even simplify that, 7 pi fourths, 8 pi fourths. Okay, so I'm going to graph. Amplitude, I do know typically I would have been going up to 1 and then down to -1, but I'm not anymore because the amplitude changed. So at the start, for cotangent, what cotangent does is it begins with an asymptote at the start. And then at the first key point, it actually will go up to the amplitude, which is going to be 1, okay, or, I'm sorry, 1/4, down to the center line, and then down to the minimum, though we can't really call that a minimum like I was saying with that cosine and sine you could have, but not with this cotangent and tangent, because these get for example, ever smaller and smaller and smaller, approaching this. Okay, so there's my asymptote, approaching it but never crossing it. There is one full period right there. What you could do is continue on. So here's my asymptote. That would be the repetition of what I started with, and then I'm going to repeat onward. So there is 1.5 cycles right there, or 1.5 periods. Alright, that's it.